Hello and welcome to another exciting Breakfast with Unity. It's been a long time, so bear with me as we see if I still remember how to do any of this stuff. Just kidding. I've been using Unity still very extensively in my time off. It's just I haven't been able to do the show. So hopefully you'll forgive me the long absence, and hopefully there won't be another long absence after this episode. But what we're going to be doing today is kind of fun. We're going to be using Recursion to create a little tree. It's going to be more like a stick figure version of a tree than an actual tree itself. But the concept is interesting and fun, and I'm sure that you can find other uses for it. So what we're going to do first is I'm just going to set up the project a little bit here. I'm just going to create a new folder for what we're doing. Create folder 93 recursion tree is what I'm going to call it. Oops. We're just going to put it here. And I'm just going to go ahead and save this empty scene into it. Recursion tree. And we'll save it directly into our new folder here. So first off, I'm going to talk about what recursion is, because we're going to be doing it a little differently than what you typically do in a computer science class. Though we're going to do one of the computer science examples first, just so that you get a general idea of how you would set up a recursive function normally. So let's just create a C# script. We're going to call this, I'm going to call it recursion tree. And we're going to open this up. And so what recursion is it's so looping is something that we've been very used to. We've created for loops, we've created, while loops, we've created lots of loops where something happens and you loop on it multiple times. Recursion is kind of like that, except for it's kind of loops within loops within loops. It's where typically when you create a recursive function, you create a function that calls itself. And so I'm going to create a really basic in factorial function. This is a mathematical concept. It's what it's used for is if you have a set of things and you want to find out how many combinations of that set without repeats, you use in factorial to figure that out. So I'm just going to create a factorial real quick. Int. So it's going to return int factorial example. And this is going to also take an int input. And the way so what in factorial is you take the number times itself times the number -1 times itself times the number -1 times itself until you get down to 1, and then 1 times itself is still 1, and you just add that together. So what this function looks like is if input is greater than, if input equals 1, then we will return 1, because 1 times 1 equals 1. We could also just do return 1 times 1, but that's an extra multiplication that might not get compiled out. It might get compiled out, who knows. So we return early in that case, and then in the rest of the cases, what we do is we call factorial example input -1. And so if I was just very quickly check to see if this works, we could just do a debug.log factorial example, and let's give it a number of like 3 or something. And we'll make sure that we'll find out if this actually just does an infinite loop. So obviously if you just did like factorial example and then called factorial example directly inside of it without a special return case, you'll have an infinite loop. It's very easy to run into infinity problems. So if you have a crash or something when you're doing fancy stuff like this, it's probably an infinite loop that you've created. Let's see what actually happens though. We're just going to throw a recursion tree on the main camera. There's a problem here. Not all code paths return a value. Oh yeah, sorry. We need to return factorial example input -1. There we go. That makes a lot more sense. So if we hit play now, we should just get a number in the inspector. or we'll get a crash. We'll see what happens. Oh, it didn't crash yet. So 1, that actually seems wrong. Oh yeah, sorry. It's return input times factorial example input minus 1. I'm probably just going to do this completely wrong, and it's not going to be very useful. 6, that sounds more right. So 3 times. I forget if it has to do times itself first. I think that's right. Let's see, is there 6? So with 2, it should just be 4, right? Actually, it's just going to be 2, isn't it? The way I've written it. Okay, I might have done this wrong. But concept is this is just the concept here. We're gonna do something fun with this. I promise. It's not just gonna be a math example. So this is just a math example, but this shows how you create a recursive function. It's probably not an actual factorial. I probably did this wrong, but I don't care. So what we're gonna do is I'm just gonna delete this, and we're going to actually do something cool with it. Now, we're not going to be calling our own function itself. What we're going to be doing is we're going to be relying on the start function to basically create new objects that also have this start functionality in it. And that's going to be the way that we're actually doing our recursion. So to start this tree, we're going to actually create a small piece of art. Very, very simple. It's going to be what the tree is made out of. So I'm going to create a cube because I'm totally an artist, and cubes are what I do. And we're going to make this cube a long cube. We're going to make it 0.1 by 0.1, and then we'll leave the z at 1. And actually, let's make it a little bit smaller. 0.05 by 0.05. There we go. So we have this little twig, and this is the twig of our tree. This is what our tree is going to be generated out of. And we also want it to be offset a little bit. So I'm going to create a empty game object to make as a parent here. Put it 0, 0, 0, and put the cube inside of it. This cube we also want at 0, 0, 0, but then we want to offset it by 0.5 so that so this is now an object. I'm going to call this tree piece. Actually, I'm going to call it a twig. And so now this twig, if we, as you can see, it starts at 0 and then it moves to 1 in the z. And this will be useful for us because basically what we're going to do is we're going to be creating more twigs off of this twig using a recursion function. And the other thing I'm going to do is I'm just going to stand the twig up on its end by rotating it in one of these directions. We'll do -90 here. And so if we look at the scene, we have a little twig here. I'm going to move it a little bit closer. I'm going to move the camera up a little bit, and then I'm going to move the camera a little closer. Not that close. Actually, maybe that's perfect. Yeah, let's do that. That's perfect. All right, so now we're going to write our function. So what we're going to do is we're going to need a couple variables here. We're going to need a public float twig length equals 1.0 f, and we're not going to probably change that, but this is just in case you wanted to have twigs of a different length. We're going to do public float spread angle, and let's just default that to, let's do 30.0 f. That's probably too much. I don't know. We'll find out. We're going to need a reference to ourself. So that's going to be public game object twig reference. And this is actually how we're going to get our recursion to happen. Is basically we're going to be spawning more of ourself. And what else do we need? Oh yeah, we're going to need public float iterations. Let's default that to 3. And public float splits equals, let's do 3 as well. So what we're going to do is for int I equals 0, I is less than splits I plus plus. We're going to instantiate twig reference. We're going to instantiate it at transform.position plus transform dot forward times twig length. So this means that our new position for this will be at the end of our twig. It basically will take the forward direction of the twig and then spawn it at the very end of it. So transform.position plus transform.forward times twig length. And then we're going to need a rotation here. And I'm just going to put quaternion.identity for right this second. And we'll see if this actually even just works. So this will just create a number based on the splits. But what we also want to do is I want another for loop. I'm probably going to screw this up, aren't I? Let's find out. Let's just screw it up and then fix it. So, so if we do one per iteration. Okay, what we want is if iterations is greater than 1. Greater than or equal to 1. Then we do this stuff. This is our early out, like we saw in our previous example, that I probably shouldn't have deleted so that we had some sort of reference there. So, we're going to instantiate this, but then we also want to make sure that if we just instantiate this, this is going to cause a crash right now. Like if I was to put twig reference inside of here, we would crash Unity. And the reason is each time one of these would come in, they would instantiate. And then the next one would come in and instantiate. And then the next one would come in and instantiate. And eventually you would have infinity. So what we need to do is we need to actually make sure that the next ones have a different set of iteration. So what we can do is, instead of using a game object twig reference, we can use a recursion tree, which is our class right here. And that way we can get this very easily. We can just do recursion tree instance equals instantiate as recursion tree. And then we can take our instance dot iterations equals iterations minus 1. So now what'll happen is eventually iterations will be 0 and it'll stop. And before that, everything will spawn itself and then spawn 2 copies. Now this is going to be a really dumb tree right now. So if we try this, I'm going to save the scene just in case we've caused a problem. Save a lot when you're going to be doing a lot of heavy loop or recursion work, because as I said, you can screw this up real easily and cause a crash. So I'm going to put a twig in here. I'm going to put a copy of the twig in here. We're going to make the twig reference itself. Make sure that shows up here. Good. And then I'm going to save the scene and save the project one more time. And we're going to hit play, and we should have the lamest tree ever made. There it is. There's a lame tree. So, and actually, it's... So, it happened the first time, and then we did quaternion identity, and so there we go. We have our twig. The thing you want to instantiate is null. Why did it say that? Oh, main camera. Okay, so main camera, we had attached previously recursion tree to see the debug output. Let's remove that. So, so if we hit play, we shouldn't have any argument exceptions, and there we go. And you'll see that we have this incredibly lame tree. So what we want to do is we want to actually spread it out, and we're actually going to use. I'm going to use the shotgun weapon that we did in a previous episode as an example. I'm going to quit this. So spread angle, is that what we called it there? Oh, awesome. That makes things real easy. All right, I didn't actually even intend that. So I'm going to just copy this logic. This is our random spread logic. And what we're going to do is... So fire rotation, I'm going to call it twig rotation. And then actually I'm going to call it current rotation. And then we will do current rotation, random range spread angle. There we go. And then we will then use fire rotation, what we're going to call it twig rotation. So that people don't know that we copied and pasted this from our shotgun code. There we go, twig rotation as recursion tree. So now if we hit save, and if we hit play, oh, messed up something. Twig rotation. Oh, so we're going to just call it turn in twig rotation. Save, play. We should have a tree, hopefully, if all goes well. There we go. We have a tree. It's a little twiggy tree. So now if we want, we can change the parameters of this. I'm going to actually move the main camera back a little bit more. So let's move it 5. Actually, let's make the twig a little bit shorter. We're going to make it 0.5 here. And then we're going to make the twig length 0.5 so that it doesn't have holes in it. If we didn't do this, here, I'll show you what happens. If we hit play right now, we would have holes between the twigs, which doesn't look right. So if we put the twig length at the actual length of the twig and hit apply, you'll see that we don't have those holes anymore. And we have a little bit shorter tree. Does that look right? Oh, okay. Well, we had to change one more thing. Because I changed the size here, I needed to also change the offset, because if you see here, our offset no longer is right at the bottom there. So if we adjust the offset to be 0.25 now, that will fix that. So if we hit play one more time, we'll have a much more tree-looking tree. There we go, a little shrub. So let's make it spread out a little bit more. So we're going to go spread angle and make it like 60. That's probably too much, but we'll do it and see what happens. And let's also make it so that there's more iterations. Let's make it so that there's 5 iterations, and we're only going to do 2 splits per iteration. See how that tree looks. Now we've got too much angle. Oh, and also we need to always apply this when we make these changes, otherwise it won't quite be right. There we go. That looks like a pretty good tree there. And what you can see here is each time it's splitting only once, and we're getting all these little child trees, and it's nice. So we have a little happy tree that we can make, and each tree will be relatively unique, just using random. And you can go crazy. I mean, but the thing is, the more iterations you do, this gets exponentially big. And also, if you do a lot of splits, it gets even faster. So, like, if we do like 5 splits and hit play, we'll have a whole bunch. Yeah, it's a very dense tree. Probably denser than you want in a game. And if we were to do just one more iteration, this becomes ridiculously dense. So, like, if we do 6 and apply, you'll see that it takes a while to even start. There we go. And if we go 7, as I said, you're not going to want to actually do this in a real-time game, probably. Though at least they're all cubes, so they should all batch. Let's see what the draw calls are at when we finish this. Oh, man, yeah. I'm tempting fate here. So stats. Oh, yeah, it's running real good right now. We now have... we've saved... Yeah, see, this is how many twigs we have. We have a lot more than you think we would have. There's just a 7 and a 5 here, and we now have 390,000 saved by batching. There's still 442 batches for some reason, but yeah. So yeah. So there's our tree. It's been 20 minutes. Kind of wanted to do one more thing. Whatever. I'm sure people can handle one more thing. I'm just going to do one more thing. So we're going to make the iterations, again, more appropriate. I'm going to do 6, but then 2 splits, so that should cut things down considerably. Let's do 5 and 3, actually. That might be better. And then spread it out just a little bit more. Oh, wait, actually, let's hit apply and make sure that we're still looking at the same thing. Yeah, and then let's just make it 40 degrees. Apply. There you go. That looks like a pretty cool little tree. So what I want to do though is we can parent these things and have a little bit of fun and make them actually move like they have wind or something. I'm gonna save this for next time. This will be for tomorrow. So anyway, thank you very much for watching. If you have any questions, please email me, pushypixels@pushypixels.com. You can also tweet me at Drakfire. That's DRAKFYRE. And thank you guys for watching. It's been a long time, and I appreciate that the audience is still out there, and I appreciate you guys' concern and support over time here. Hopefully everything went smoothly with this video. I'm probably going to go to the comments and find out that everything's broken, but hopefully not. And you guys have a great one. And I will catch you tomorrow with another Breakfast with Unity, probably at 10 a.m. I will schedule that as soon as I can. Thank you very much, and you guys have a great day.